Hello everyone, in this video let's discuss about collision. Elastic collision in one dimension. Let the particles 1 and 2 moves along positive x-axis with velocities v1 and v2 before the collision and v1 prime and v2 prime respectively after collision. Since the external force on the system is 0, the linear momentum of the system will be conserved. Using conservation of linear momentum, we write momentum of particles before collision equals momentum of particles after collision. So we formulate m1 v1 plus m2 v2 equals m1 v1 prime plus m2 v2 prime, or we can write m1 v1 minus v1 prime equals m2 v2 minus v2. Let's call this as equation 1. In the case of perfectly elastic collision, there is no dissipation of energy. Therefore, mechanical energy of the system is conserved. So we can write mechanical energy of the system before collision equals mechanical energy of the system after collision, and we formulate as half m1 v1 square plus half m2 v2 square equals half m1 v1 prime square plus half m2 v2 prime square, or we simplify this to m1 v1 square plus m2 v2 square equals m1 v1 prime square plus m2 v2 prime square, or m1 v1 square minus m1 v1 prime square equals m2 v2 prime square minus m2 v2 square, or m1 v1 square minus v1 prime square equals m2 v2 prime square minus v2 square. Let's call this as equation 2. On dividing equation 2 by equation 1, we get v1 plus v1 prime equals v2 plus v2 prime, or we can write v1 minus v2 equals v2 prime minus v1 prime. We can see that the term v1 minus v2 represents velocity of approach, and the term v2 prime minus v1 prime represents velocity of separation after collision. So we can write in the elastic collision velocity of approach equals velocity of separation. Now let's discuss about coefficient of restitution. In a perfectly elastic collision, we have just derived that velocity of approach equals velocity of separation. For perfectly inelastic collision, velocity of separation becomes 0. In general, the collision is neither perfectly elastic nor perfectly inelastic. In such cases, we write velocity of separation equals E times velocity of approach, where E lies in the interval 0 and 1. The constant E depends on materials of colliding bodies. The constant is known as coefficient of restitution. The coefficient of restitution is 1 for perfectly elastic collision and 0 for perfectly inelastic collision. For all other collisions, E lies between 0 and 1. Perfectly inelastic collision. The collision which causes dissipation of kinetic energy is called inelastic collision. In an elastic collision, kinetic energy can be dissipated partially or fully. The full dissipation of kinetic energy occurs when a moving object collides with a stationary object which seizes the motion of the moving object. The kinetic energy transforms to heat energy, sound energy, wave energy, intermolecular vibration energy. Let's consider the case of inelastic collision when partial dissipation of energy occurs. The particles of mass m1 and m2 moving with velocity v1 and v2 collides. After collision, they stick together and move with a common velocity v. As the net external force on the two particle system is 0, the linear momentum of the system will be conserved. So we can use conservation of linear momentum and write m1 v1 plus m2 v2 equals m1 plus m2 multiplied by v. The common velocity of two particles after collision is v equals m1 v1 plus m2 v2 divided by m1 plus m2. The amount of kinetic energy dissipated in this inelastic collision is delta Ke equals half m1 v1 square plus half m2 v2 square minus half m1 plus m2 v square, or this will be equal to half m1 v1 square plus half m2 v2 square minus m1 plus m2 multiplied by m1 v1 plus m2 v2 divided by m1 plus m2 whole square. Again we simplify this expression to half m1 v1 square plus m2 v2 square minus m1 v1 square plus m2 v2 square plus 2 m1 m2 v1 v2 divided by m1 plus m2. On simplification we get the simplified value as half m1 m2 divided by m1 plus m2 v1 minus v2 whole square. This value is a positive value, and the positive value of kinetic energy dissipation shows that there is a loss of kinetic energy in the inelastic collision. Collision in two dimensions. Two particles located on xy plane at position vectors vector r1 and vector r2 moving with velocities vector v1 and vector v2 will collide if the vector v1 minus vector v2 upon modulus of vector v1 minus vector v2 equals vector r2 minus vector r1 upon modulus of vector r2 minus vector r1. These both vectors are unit vectors. So we conclude that the necessary condition for the collision of two particles moving with constant velocity are: first, both particles must have different initial position. Both particles must have different initial velocity. Relative velocity of first particle with respect to second particle needs to be towards second particle and vice versa. So this is the necessary condition for collision of two particles moving on xy plane. Elastic collision in two dimensions. When two particles moving in two-dimensional frictional surface with no external force on each particle collides, the momentum of the two particle system remains conserved. So we apply momentum conservation and write m1 vector v1 plus m2 vector v2 equals m1 v1 prime vector plus m2 v2 prime vector. If collision is elastic, the kinetic energy of two particle system before the collision and after the collision will remain same. So we can write half m1 v1 square plus half m2 v2 square plus half m1 v1 prime square plus half m2 v2 prime square. Both energy are equal. So this is about the collision in the two dimension. We apply conservation of momentum, and if the collision is elastic, we apply the conservation of energy. Thank you for watching this video.